Alright, we're going to do a circuit analysis on a series circuit with 4 loads. We are given each resistance value and our supply voltage. We're going to do this in a spreadsheet. We're using Google Sheets. So we're going to create a new sheet. I'll move this over here so I have these two together. I would like to rename this sheet Formulas. And I can do that because in each of these tabs, I can create a new tab for each different type of circuit. One might be a series circuit, one might be parallel. One might be a series circuit with 5 loads, and I know the resistance. One might be series circuit with 10 loads, and I just know the current, etc. So there's different ways you can title each of those tabs depending on what you want to solve. Now what I like to do is select the whole sheet right here and make all the cells size 14 font. I just like to do that. I think it's easier to see if I make it bigger. And we know we have 3 loads, so I'm going to do what I've done in the past, is put in the resistor number. And I'm also going to take advantage of patterns by selecting the first 2, left click here and drag and continue the pattern. And I know that this row is going to be my totals. Now in here I have my ohm values, and you could do this in any order that you like, depending on your preference. Voltage, current, and then we'll do watts. And that's all we can do. This would do a complete circuit analysis. I'm also going to highlight all these and down to create a grid, a border, all borders, and that also makes it easier to see. Now we're going to be doing some formulas off of our Ohm's law wheel here like we've done in the past. So we have a 100, 220, 330, 1K, and I'd like to look at this circuit at the same time that I'm doing my analysis. So I'm going to left click this tab and drag it out so I can put my spreadsheet outside of the browser window and minimize. You'll notice over here I still have this open, and I'm going to click the middle tab here and drag this over. So now all the rest of my tabs are still here. Here's my circuit, and over here is my spreadsheet. And I can resize this, make my life a little bit easier when I'm doing a circuit analysis. So I'm going to go ahead and type in my 100, 220, 330, and 1000. Remember, 1K means 1000. Now I'd like all my numbers to be to 2 decimal places. So I'm going to highlight all my cells where I'm going to be doing my math, where I'll have all my answer values, and I'm going to tell the sheet with these 2 tabs you can decrease or increase 2 tabs. You can also format number and select here, and this will also not only put in a comma but put everything to 2 decimal places. Just a couple different ways you could do that. Now I'm given my total voltage, so in my total column I can put in my total voltage, 12 volts. Notice it automatically gave me the 2 decimal places. Now these are my known values. These are what's given to me in the drawing. So I can select highlighting, which looks like it's hiding on me. There it is. I'm going to highlight those cells, and I'm also going to highlight that cell because I want to remember later on these are my known values. These are the values you can change, and the rest of the sheet should react. Well, we know in a series circuit to figure out total resistance, we add up all of our loads. So in our total, we're going to add up the sum, okay, sum of what? I can now left click and drag and highlight all these cells I want to add together and then hit the enter key. And now it has added all those up for me. Now that I know my total resistance and total voltage, I can solve for total current and total wattage. When you have two known values, you can solve for any unknown. So just for the heck of it, in this situation, instead of using the easy formula E over R equals I, let's figure out what our wattage is, knowing our voltage and ohms. So I'm going to come over here to our circuit rules. So I want to solve for wattage. Okay, so there's three different ways to solve. So I want to solve for wattage because I want to do this differently. And I know the voltage and the resistance. So when I look in the wattage area of my Ohm's law wheel, what I usually do is I look at, okay, I know my ohms, which two formulas use ohms? So that would be this one and this one. So immediately I know I can't use this formula. Okay, another way to figure out wattage, when I know ohms and voltage, I look at, okay, I don't have my amperage. You can see my amperage column is empty. So I can't use this formula. So I'm down to this one, E squared over R, the voltage squared divided by resistance. That's the only one I can do to solve for my total wattage. So I press equals because I immediately am telling this cell I want you to perform a formula, an operation. And I want you to take whatever the total voltage is, whatever's in this cell, and I want you to square that. And you do that by pressing Shift and the number 6. And you get this funny little caret sign. Almost looks like a teepee. That means you are raising this to a certain exponent. And I'm squaring it, right? Raised to the second power. Then I want to divide that by the resistance, whatever's in this cell, B6. B6. So then I hit enter and it should perform the formula. Now I can get away with not using any parentheses because the order of operations, PEMDAS, is going to be performed in the correct order. Now I can take the same formula all the way across if I had the known voltages, and I don't. So the only place I could do that particular formula was right there. Now I'd like to solve for the current. Well, now I have some options. I could use the usual voltage divided by ohms, E over R. And if I go to my amperage section, we see it right there, E over R. Or if I wanted to utilize the fact that I have my wattage solved, I could take the wattage divided by the voltage. The other formula that I could use is the square root of wattage divided by resistance. Just to be different and to see how we would enter this in, let's perform this square root function. So I want to take the wattage divided by resistance, the square root of that. So I'm going to use my equals, right? I'm doing an operation. And the way you do square root is start typing in the word square. Now notice as soon as I hit S, a whole list of functions comes up, and square root is right here. If I typed in Q, it would narrow it down to other functions. Well, I know I want square root, so I'm going to select that. So I want the square root of what operation? It is now in parentheses for me. and I would like to take power divided by resistance. So whatever my wattage is, whatever's in this cell, divided by my resistance, my ohms, whatever's in this cell, and I have to close that parentheses up. You can't leave that open, so I will close that up and hit enter. And that should be the total current in this circuit. Now if I want to check this, remember for current, total current, I said I had 3 ways that I could solve it. Well, let's use this formula just below here, since we have all these known values, and let's see if we get the same answer. So equals, I'm going to take power divided by voltage. Power divided by voltage. Notice I'm referencing cells. Hit enter, and I get a different answer because I haven't told this cell to narrow down to 2 decimal places. So I will shrink this down to 2 decimal places, and we see we have the same answer. If I tell each of these cells to increase decimal places, it should continue. All right, let's highlight both and increase. See, we have the same answer here. All right, let's do a different formula down here. The one that's left to solve for amperage is our normal E over R. So equals voltage, whatever's in this cell, divided by total resistance in this cell, and hit enter. And now I'm going to highlight all those cells and leave it at that. We can see we have the same answer. So that is a great way to verify. And you can do this with any of the formulas in this wheel. In my parallel circuit, I showed you how you could cross-check wattage. Now here we solved wattage with this formula. Remember, for watts, we used E squared over R. And I told you you could also take the sum of all your wattages. So we'll take the sum of what? I'll highlight all these cells and hit enter. And when we get all these cells filled in, this answer should equal this answer. Whether you're in series or parallel, this cross-check with wattage is the same. Okay, enough of that. Let's get down to solving this circuit. So I know that the current is the same in a series circuit. No matter where I measure my current in here, it should be the same. So I'm going to tell this cell I want you to equal whatever is in this cell. Enter. Okay, I want you to do the same. I want you to equal whatever's in this cell. All the way down. And now I'm going to make everybody all the way through. I'm going to make all the decimal places the same. Okay, now the current's the same. If I were to double my voltage, the current should react and the wattage should react. I'll click undo to put everything back. Now to solve for voltage, I'm going to use I times R. That is in our circuit rules here. I want to solve for voltage, I times R. Okay, so I'm going to tell this cell I want you to equal I times R. I want to create the same formula for each row, so I'm going to get the little X, left click and drag, and it'll perform that same formula for each row. For wattage, I want to use I times R, the word pi, or I'm sorry, I times E, apologize. Okay, so I times E, and I want that the same all the way down. Okay, notice how it added all those up, and my answers are the same for my wattage. And I have now done a complete circuit analysis on this circuit with these known values. So if my instructor were to start changing the resistance values, let's say 200 ohms, We'll make this one 500 ohms. Notice how the sheet reacts automatically. Everything adjusts, and I have every answer I need right there. If my teacher decides to change the voltage to 24, everything reacts.